Hey everyone, welcome to Monday. We're going to continue on with our circle stuff. We're going to talk about inscribed angles today. These are a little bit tricky, so try to pay attention. Again, there's going to be lots of algebra problems to try to figure out some angle measures and some arc measures based on what we're learning. So pay attention as we go through. So an inscribed angle is an angle whose vertex is on a circle and then the sides contain chords of a circle. So basically it's like a big chunk out of the circle from one side to the other. So we see our picture. We have in our circle here, circle G, the minor arc of DF is what they call the intercepted arc for the inscribed angle BEF. So the angle, the vertex at point E here, is what we're looking at to kind of go all the way across. The sides of that angle go across to create our arc. If we kind of think back to what we were looking at with central angles, it's kind of the same thing. So you could think of, do it in blue, you could think of the central angle from point G out to D and F creates that arc. That's the arc they're talking about when they talk about an intercepted arc. Is an arc from like those 2 points, the endpoints of the arc, all the way across the circle to some other point along the other side of the circle. It doesn't necessarily even have to be across like this one is. It could be, if I do it here, I'll do one in purple just to show you. I could actually have an inscribed angle that looks like this. So now I have a new angle, let's say at J, that's still inscribing and intercepting the same arc that angle E does, but it's just a completely different angle than what we see. What you're going to find in a minute, though, is the measure of angle E and J are going to be the same, because you can kind of see on the bottom. So the inscribed angle theorem, like I just said, is an angle inscribed in a circle. The measure of that angle is going to equal 1/2 of the measure of the intercepted arc. So if I just called this arc, let's say 70 degrees, then I know angle E and angle J, which I drew in, is going to be 35 degrees because it's 1/2 of the arc. Does that make sense? So you kind of think of it that way, and what we're looking at is just when you're given an angle measure for an arc, then an inscribed angle is going to be 1/2 of that. If you're given the inscribed angle measure, then for the arc, if you're trying to ask to find the measurement of the arc, you're just going to double the inscribed angles measure. Like I say, if 2 inscribed angles intercept the same arc, like I've done, drawing in angle J, those are the 2 inscribed angles, E and J. Those angles are going to be congruent, so they're going to equal. Because the angle measurements have to be 1/2 of that arc measurement. So, work on another example. It's the same circle. We have circle G. We're told that arc DF is 60 degrees, or 90 degrees, sorry. So I know this is 90. We're asked to figure out the measurement of angle BEF, or angle E in this instance. We're trying to find this measurement. We know that it's 1/2 of the arc measurement, so 1/2 of 90 degrees is going to be 45. So just remember, if you're given the arc, the inscribed angle is 1/2. If you're given the inscribed angle, the arc is twice. Make sense? Okay, here are some problems for you to work on. Go through and figure them out, enter the answers in the Edpuzzle, and then come back and check your work. All right, so what we should see is, like I said, we talk about what measurement are we given. If we're given the inscribed angles measurement, which we are in angle 1, question 1, we're told angle B is 36 degrees. My arc has to be 2 times that because I know B is 1/2 of the arc. So that makes the arc 72 degrees. In question 2, we were given the arc length, or the arc measurement, sorry, which is 62. So 1/2 of 62 is 31. And in the last one, we were given the angle measurement was 113, which is 1/2 of my arc measurement. So now my arc is going to be 226. Does that make sense to everyone? Kind of seeing where this is going now? Okay. Here's some more problems. We're bringing in the algebra now, so you're going to kind of work through it and find the measurements that way. So again, try these and then enter your answers into Edpuzzle and come back and check your work again. All right, so what we should have, you should have found that angle U. Sorry, this was a different one. This was the inscribed angles opening onto the same one. So we have angle U and angle V opening up to this arc TW. So they're going to equal, so I can set them equal to each other, substitute in what I know. I know angle V is 30, so angle U is going to have to be 30. To find angle T, again, I look and I say they're both opening up on arc U, so they're going to equal to each other. They gave me equations for both of these ones, though, so I just set the equations equal to each other. We find out that x equals 5, so I plug that back into my measurement for angle T, and I find that angle T is 19, which also makes angle W 19. Question 6, again, A is opening up onto the same arc that D is, so A and D are equal, so 6y minus 2 is going to equal 5y plus 8. Do our algebra, we find out y equals 10. Plug it into the measurement for angle A, and we find angle A was 58 degrees, which also makes angle D 58 degrees. And then for C, same thing. C and B open up on the same arc, set those measurements equal to each other, solve for x, plug it back in, and you find out that C was 45. So is that making sense? You know, the tricky part of it is the two angles opening up on the same arc, remembering that they're congruent. So just remember that if two angles open up on the same arc, those angles are congruent. Okay. We can inscribe angles. We talked before on last Thursday about inscribing polygons inside circles. Well, those inscribed polygons have some rules about their angles as well, because now when you inscribe a polygon, you've automatically inscribed angles onto your circle. So with an inscribed polygon, it's just a polygon where the vertices are on the circle. So we have we either can look at that and say we have one four-sided polygon, or we have two triangle polygons. But there are some rules we're going to talk about in a minute. So an inscribed polygon is if it's a triangle, and that triangle intercepts a diameter. So if one of the sides of the triangle is a diameter of the circle, then or it's opening up on a semicircle, then it's a right angle. So in our example here, both of our triangles, we kind of split the shape up into two. ABD is a triangle. I'll draw it in red. This triangle, where it's a diameter, that makes that a right angle. We kind of look again, BCD is the same thing. That tells me that angle C is a right angle, which will help us with our next rule when we talk about non-triangular quadrilateral inscribed angles. So if you inscribe a quadrilateral, then the opposite angles are supplementary. What I do is I'm going to open up my highlighter here with purple. And that's telling me that angle B, not purple, yellow again, is going to be supplementary, or add those together, they're going to equal 180 degrees. So it's always opposite. No matter where they are on the circle, they're always opposite each other. So it's going to be, even though they may be very close, if D was moved way over closer to A, it's still opposite B. The same thing here is when I kind of switch over now to purple for my highlighter. Angle A is supplementary to angle C, which based on the triangle rule we knew, because both of those triangles bisect the, or they intercept, I guess they're calling it, the parts of the side, one of the sides of each of those triangles is the diameter. They're both right angles, which I know, right angles are 90 degrees. They add them up to 180. So that's where you can see opposite angles need to add up to 180. Okay, let's move on. We got some problems on this now. So it's just kind of going through telling you what the rules are there. So we have our example. We're trying to find angle K. We have an inscribed triangle, but neither of the sides is a or none of the sides is a diameter. So we're going to have to solve for it. So now we got to kind of think of how we're going to figure this out. So what I do know from our picture is my chords from K to L and from K to M, those arcs, I meant arcs, not chords. Those arcs are congruent. They've told us they're congruent. So remember from Friday's lesson, if arcs are congruent, then the corresponding chords are congruent. So that tells me that these two sides here of my triangle are congruent. So now I look at my triangle and I see I have an isosceles triangle. So okay, now I can piece together the solve for x. I know the angles of triangles add up to 180. So if I want to kind of just shorthand it first, angle K plus angle L plus angle M is going to equal 180 degrees. So let's just plug it in my equations. 5x plus 5 plus 3x plus 5 plus 3x plus 5, because angle L and angle M are congruent, equals 180. Combine all my like terms. I end up with, what's that, 11x plus 15 equals 180. Subtract 15 from both sides. I end up with 11x equals 165. Whoops, x. Divide by 11. I find out that x equals 15. So I can plug that into my equation over here. I get 5 times 15 plus 5. That's going to equal 80. So now I know that angle K, the measure of angle K, equals 80 degrees. Does that make sense to everyone? You're just going to kind of have to piece together what's the picture telling you, what information do I have, how can I solve for the other side, or how can I solve for a variable, or the measure, or whatever they're looking for. All right, so here's some problems for you. Take a look at them, work them through for a minute, and then come back and check the work that you've done. Okay, so we've asked to solve for the x variable. So the first one is not angle x, they actually wanted the x variable. And then what an angle measure is. So we kind of look and see the one side of my triangle goes through the center point, so that tells me that it's a diameter. So that tells me then that my other angle there at angle Y is the right angle. So I can set angle X and angle W added together are going to equal 90 degrees. So then I just plug in the equations, solve for X. We find out that X is 39. They wanted the measurement of angle W, so I plug 39 in for X there, and I find out that angle W is 51 degrees. Does that make sense to everyone when you look at it? Okay. Same thing on problem 3 and 4. One side of my triangle bisects or goes through the center, makes it a diameter. So the other two angles then, angle S is the 90-degree angle. The other two angles are going to add up to 90. Plug in your equations. Solve for X, you get 16. They wanted the measurement of angle P, so I plug 16 into the 4x minus 6, and I find out that angle P was 58 degrees. Does that make sense to everyone? That's working out? Okay. Let's move on. A couple more problems here. Here now we're talking with the quadrilaterals. So remember, opposite angles are supplementary. So go through, solve for the variables, solve for the angle measures, and then come back and check your work. Okay, so for problem 5, angle R, supplementary to angle P. If angle P is 75, that automatically makes angle R 105. I went through and solved for X first because I knew 75 plus 3X is going to equal 180. I solved for X. I did an extra step that I didn't need to do. For angle 6, I see that 6 is supplementary to angle Q. So Q is 110, makes angle S 70. They have to add up to 180. 7 and 8, now they've actually given us algebra for all the angle measures, equations. Now we actually have to solve for the variable. They wanted the measure of angle W. I look, angle W is supplementary with angle Y. So I plug in those equations. X plus 18 plus 2x is going to equal 180. Work it through, solve for x, find that x is 54. Plug 54 back in, I find out that angle W was 72 degrees. Angle 8, or question 8, we look. They want x. X is supplementary to, I wrote y, but it should have been z. Sorry about that. This should be z. I had the right equation though. So 3y minus 7 plus 3y plus 1 equals 180. Work it through, y was 31. Plug it back into the x equation. I find out that y is 86 degrees. So if you quickly wanted to double check it to make sure, like we're talking quadrilateral, so those angles have to add up to 100 or 360. So I have one angle 72. So like this angle 72. I know now this angle is, sorry, this should be angle X. Angle X is going to be 86. Hopefully this works now and do it. So this is going to be 108. So now it's going to make this one 86, 94. So if I add those up, 94 and 108 is 202. 72 and 86 is 158, which adds up to 360. So it did work. But that's how you can check your work to make sure you have the right stuff. Does that make sense to everyone? That is inscribed angles and inscribed polygons. It just about finishes up all the stuff we really need to know for circles with angles and stuff. So kind of work on your homework. Tomorrow we're going to work on, I believe, don't quote me on it, but tangents to kind of tie into the sine, cosine, and tangent stuff we did. And then we'll be finishing up with review on our area on Wednesday, and then review Thursday for online tests and in-class tests on Friday and Monday. And that'll be the end of the term. So have a good night, and I will talk to everybody on Tuesday.